Hello, my name is Nilakshan. This is my assignment of DSA module. I built MERN-based interactive game application that includes user account system, a hard puzzle game using an external API, a multiple choice quiz using the OpenTDB API, and a persistent scoring and leaderboard system. In this video, I will explain the software design principle I used, how my application uses event-driven programming, interoperability with APIs, and virtual identity and authentication. My project is structured using clear separation between the front end and back end. I divided the application into two main folders. One folder for the front end built in React, one folder for the backend built with Node.js, Express and MongoDB. This separation follows good software architecture practices such as low coupling and high cohesion. My components remain loosely coupled because they communicate through simple interfaces. The front end talks to the backend through only REST APIs, not direct function calls. The hard game and quiz game don't depend on each other. They only read shared values like scores, chances and level from local storage. Here is an example. This shows low coupling. My game doesn't care how the backend stores the score. It only sends data and gets response. This makes my architecture scalable and easy to modify. In the backend folder, I also kept the code modular. The models folder stores the user and score schemas. The routes folder contains API endpoints such as API user, API score. The controller folder contains a function for login, register and updating score. The main server.js only set up Express middleware and connections. I choose this two folder architecture because it's standard for MERN projects, scalable, easy to debug, and it allows me to update either side, the front end or back end, without breaking the other. It also makes the code clean, structured and easier for future expansion. My entire game is driven by events, user actions and timer events trigger game updates. Here you can see when user enter the count of carrots and click submit answer button, it triggers the event and it navigate to quiz challenge page, and after click the answer of the quiz, again is trigger the event. Here you can see the code of these two button click events. This is for quiz challenge and this is for button click of hard puzzle. When the user clicks these buttons, event handlers are triggered. This function updates the score, reduce chances, display animation, and navigate to different game screen. This event fires every time the user types a number in the hard puzzle. Here you can see this timer triggers every second. It controls difficulty by reducing allowed time at higher levels. If the timer reaches 0, it triggers the game over events. If the timer reaches 0, it triggers the game over event. When the user presses login or sign up, an event sends to the form data to the backend. Here's the code written to the sends the form data to the backend. Handle submit. My application interacts with two external APIs and a backend API demonstrating interoperability. One is Heart API. Another one is Quiz API, OpenTDB. This API returns a random parcel image and the correct caret count. I fetch it, display the image and compare the user's answer with API result. This API returns computer science quiz questions with multiple choices. I randomize answer so the correct answer is not predictable. This allows users score to persist across sessions and appear on the leaderboard. And backend API, here you can see the API endpoints update score and get leaderboard score. My application includes user identity management with secure authentication. I used Bcrypt to hash password before saving them in MongoDB. This prevents attackers from seeing real password. Here you can see the hash password saved in MongoDB database. This backend generates a JWT token so users can stay logged in without exposing sensitive data. I choose Bcrypt and JWT because they are secure, widely used in the industry, lightweight, and integrate perfectly with React and Express. Now I will show what I used, what alternatives I considered, and why I choose my final approach. I choose functional components with React hooks instead of class-based components. If I choose class-based components, that increase complexity without providing meaningful benefits for my game. I deliberately used local storage because my game state is very simple. Redux or Context API would introduce unnecessary complexity, which is too heavy for a time passer game. I use native timers because they are fast, lightweight, and reliable. I consider libraries like React Timer Hook, but they add unnecessary dependencies and reduce control over the countdown animations. I choose MongoDB because my data scores users tokens, is flexible and doesn't need strict relationships. SQL requires fixed schema migrations and joins, which slows down iteration for a new game prototype. I choose the native fetch API. Axios is more powerful but adds another dependency. For two simple requests, fetch is enough and keeps my bundle smaller. React Router provides smooth transition between game screens. Using normal page reloads would reset state, reload scripts, and break the flow of the timed game. These choices were not random, they were deliberate and based on evaluating alternatives, scalability, simplicity, performance, and user experience. This allows my game to run smoothly, load fast, and remain easy to extend in the future. My MERN-based game demonstrates clean software architecture with low coupling and high cohesion, strong event-driven interactivity, secure identity handling, and effective interoperability with external APIs such as the Hard Puzzle API and the OpenTDB Quiz API. Thank you for watching.